Welcome to Webinar Wednesday. On behalf of the Powder Coating Institute, thank you for joining us for today's webinar, Carbon Footprint Reduction and How It Will Impact Powder Coating, presented by Marty Sawyer with Trimac Industrial Systems. Before we get started, I'd just like to remind everyone that all attendees are on mute, so if you have any questions along the way, please type them in the questions panel. The speaker will address the questions at the end of the webinar. If we run out of time, there will be contact information on the closing slide if you have additional questions. This webinar is being recorded and will be available through the PCI store within 2 business days. All attendees will receive a brief survey after webinar. Please take a few moments to reply. We appreciate your feedback as PCI continues to develop new programs to offer the topics and training you need. Now I'd like to introduce the presenter for today's webinar. Marty is CEO and owner of Trimac Industrial Systems, which manufactures infrared and convection oven systems for paint and powder coating applications. In 2017, she added the ProTherm electric infrared to the brand family to complement Trimac's gas catalytic, convection, and washer technologies. Marty serves on the board of the Powder Coating Institute, president of the Central States chapter of the Chemical Coaters Institute, a member of NFPA, and the Industrial Heating Equipment Association. Thank you for being here today, Marty. Take it away.
Thanks, Kevin. Well, glad to get started. Thank you, everybody, for coming on board. This has been a speech I have been working on for about a year. A lot of reading, a lot of thinking to try and figure out how do I want to present this content. So let's get started. So as most people know, you hear about right now, this speech could not be more timely, and considering I submitted it last year, I could not have picked a better time because it's everywhere right now. And so if we talk a little bit about what is carbon footprint, on the screen is a basic description, but basically it's how much greenhouse gas do you produce or are you responsible for, directly or indirectly, and that's converted into a ton of carbon dioxide. The thing that I find people don't get, it's not very well handled in the media, and it's a very confusing concept, but in reality, it's fairly straightforward, is scope 1, scope 2, and scope 3. So scope 1 is yourself. That is all the CO2 you generate in your company, directly through your equipment and what you do for a living. Scope 2 is your fuel, all your indirect purchases. So basically the electricity and the natural gas that you purchase. And scope 3 is basically everything else. So all your vendors, all your end of life for your products, flying on planes, driving to work, all those things are your scope 3. Mostly what we're going to talk about today is scope 1 and a little bit of scope 2, because scope 3 is so far beyond what I can even mentally get my arms around. We just got to start with scope 1 and scope 2. Start at the beginning. So a little bit of background. So there's a lot of little facts that I thought was really interesting, and that a lot of different sources for this, but this is pulled all from either government sites or other large carbon reduction sites. I tried, if it was something specific to the industry or something that was really shocking, I tried to cite where it came from, but most everything else came from everything came from published sources. So if we look at the entire market of electricity that is generated from fossil fuels right now, it's a little over 60%, 20% renewables and 16% nuclear. That's, we've heard that a lot. And one of the things they talk about is, how do we electrify when you're still getting it from coal? What are we really accomplishing? I can't solve that problem today, but I can give you some strategies. If we look at the greenhouse from electricity, be able to make electricity, it's really some interesting numbers that right now there's more carbon being, there's more carbon being produced through electricity generation than there is actually in fossil fuel burnings. But that's kind of the whole point of why they're trying to convert to renewables. And another great statistic, 77 quadrillion BTUs are consumed in the US. So I had to Google it because I didn't know it off the top of my head. A quadrillion is a million billion. So 77 million billion BTUs is what we consume in the US. That is a lot of power. So powder coating, if we start to look at that, solvent-based is the big push that we can make to reduce carbon footprint in our industry. So DSM, which is now Covestra, did a study several years ago, and they did a bunch of analysis, and they came up with this study. Upwards to 60% is what you get by converting from solvent. And when we look at the heat side of what we do, 2/3 of industrial energy demand and 1/5 is of the energy consumption in the world is based on industrial heat. So we consume a lot of that 77 quadrillion. And what makes it more challenging is we make the heat in our plants. We don't transport it. You can't really transport heat energy. You have to make it. You have to have a burner. You have to have something that generates the BTUs. So just in case anybody doesn't understand what a BTU is, it is that energy. It is, the energy it takes to raise a gallon of water 1 degree. And that's the scientific, but that is the energy that we're all talking about here. And I'm going to try and stay in BTUs, even though we may be talking about KWs, just to keep the nomenclature straightforward. So when we burn a fossil fuel, basically we're taking the CH4 and that's typically what we do in our industry. And if we sit there at the bottom here and look at the pounds of CO2 per million BTUs, so you can start to see why natural gas has almost half of the CO2 of coal. Now, in realities, if we looked at electricity right now, now this is you burning those to generate electricity as a point of reference is almost 250. So it's really interesting how you don't see that in the media very often, that electricity right now produces a whole lot more CO2 than us burning natural gas in our plants. So the electrification movement, you may have heard about this. There was actually just a conference a couple months ago all about this. And these are the kind of tactics. We're not going to talk about these. These are things you can easily Google and see what is available out there of how people are trying to deal with the CO2 that we're generating. Because most of the true informed electricity producers realize that in heavy industry, we can't get rid of natural gas. It'll never happen. But can we manage the natural gas? Can we manage the CO2 a little bit more effectively? And these are those tactics. If you have not heard about hydrogen as a new energy source, you should do some Googling. There is a lot of research being done in adding hydrogen to the natural gas stream in industry. Basically having the burners consume some natural gas. There's research being done on all forms and significant research. That there are some issues with hydrogen. It is, as if you remember the Hindenburg, it's really flammable, but it does have some real positives. But there is a lot of steps between here and there to be able to effectively use hydrogen. But it is probably the most sought after research right now of how to reduce long-term the CO2 implications of natural gas. But there's lots of things that have to be worked out technically to make sure that that's a viable approach. So I threw this in here just because I thought we don't talk about nuclear very often. And I was surprised to learn it's the most expensive utility. It's probably partly because we don't use very much of it, but we still get almost 20% of our energy there. France is almost exclusively nuclear. And I did not know this fascinating fact, but a bunch of universities in the US have little small reactors that they use for research and other types of power needs. And where the industry is going is away from the big, huge natural gas or nuclear plants that we've seen in our lifetime. They're going to these small modular plants, which are much safer, much more well-designed, much more, the risk is, significantly less, even with the amount of redundancies. But right now, who knows? There's a lot of political implications there that have to be dealt with. So if we get straight to manufacturing, these are the things that are really driving it. And you probably hear in the news right today that the new Inflation Reduction Act, there is $370 billion in that just for climate change, just to manage and invest in climate change technologies. There are a lot of executive actions that are being talked about. There is the SEC, Securities Exchange Commission, is talking about a massive rule that if this goes into place will be dramatic, in my opinion, and that it will require all public companies to report their scope 1, 2, and 3 emission results, which means they will have to do so much research and investigation and asking their vendors, asking us, what's your carbon footprint? What's your carbon footprint? What's your carbon footprint? Because we will have to supply that data because we will be their scope 3. So this is something we need to pay attention to because a lot of our customers are Fortune 500 countries. Anybody who's public will have this issue. So a statistic that I saw when they're talking about it, you've heard there's consultants galore popping up everywhere trying to help people and make money off of this. But $5 trillion in the next 3 years being invested annually. That's $15 trillion being invested in this space. And to do this, they have to retire a lot of equipment. So a lot of what we do for a living, that equipment's going to have to be changed out. So, this is across the US, it's not just our industry, but it's still 11 trillion of assets to be retired. So these are the things that are slowing the change. The reality check on all of this is that we all know the electrical grid can't begin to handle electrification of what we do. It's not even in a ballpark of a discussion. There's no possible way. So heavy industry just doesn't have many options. The steel industry is doing a lot of things to reduce their reliance on coal. So, the electric arc furnaces, there's a lot of things in the steel industry because they're really, the manufacturing of steel is really the big driver in heavy industry. And to do any of this is going to be expensive. So, does the economy want to absorb that further inflation that will come from us having to pass on all these energy costs? So when we look at, where those costs are being driven by is all these new technologies. None of these are going to make our lives cheaper. They're all going to add cost. And they haven't figured out how to do it yet. And they haven't figured out the transportation, the distribution. There's a lot of things between here and there they got to figure out to have any kind of mass adaptation. And when we talked about the SEC rule, the thing that's probably cooled that a little bit has been the Supreme Court came out about a month or so ago on restricting the powers of the EPA on their climate change regulations. So that has a cooling effect on this, but I personally don't believe it's going to cool it that much. There will still be an effort to drive that through, though time will tell. As a little statistic, 90% of Fortune 500 companies have a report on sustainability. And if you look at the time frame up from 20, that is 20%. That is a massive increase. And several of them have announced formal targets. They will be carbon neutral. They will be net neutral. However they claim their targets, they are publishing, and companies that are in our industry. So I put this in here. So I was making a flight the other day, and this popped up on Southwest. It's just everywhere. It's permeating our lexicon now. It is everywhere. So even when they talk about how do you want to make your plane ride and do an offset, because planes really aren't going to run on electricity anytime soon. So that's the only option that industry has. So let's get to the meat of this, and let's get to the powder coating piece. So in reality, to reduce carbon footprint in powder coating, these are the things these are your choices. This is all there is. What are you using for powder? What are you using for your washer chemistry? What kind of equipment do you have? How are you running that equipment? How are you handling the waste energy, the waste heat, waste water? All those kind of things consume energy. And then how well maintained is your equipment? Your whole process. If you're not doing maintenance, you have an inefficiency. Because the only way people are going to make any substantive improvement is to use less gas, use less energy, and be more efficient. So when we look specifically at the powder industry, I have not yet found a powder manufacturer who does not have a green target. I'm sure they may be out there, but I haven't found one yet. We're starting to see a lot more energy around low temp powders, which decreases the temps in the oven, which is a direct gas savings, which is a direct CO2 reduction. There's more discussion about, can you reduce the amount of mill build, the amount of powder you have to use to coat the part. Again, that directly relates to how your process runs. So, are you throwing away the powder? Are you reclaiming the powder? All those things factor into how much CO2 you are generating. And let's be honest, there's more formulation changes to come. A lot of the resin companies are working very, very hard at this to find more ways to drive down the temp or increase the performance of the powder so that it reduces, and particularly to the point of carbon reduction. So now let's talk about the washers. Nanotechnology, zirconium type technologies, but nanotech, that's a type of nanotechnology. Those don't need heat. Well, if you don't need heat, you don't need natural gas. There's ambient temperature chemistries out there. You've got your wastewater. The idea of having 2 and 3 heated tanks anymore, you're seeing less and less of that. So, you can also look at some other ideas when we talk about the washers, is you could have an electric heat versus natural gas. That's not the most inexpensive way to heat your water, but it is a possibility. The burner efficiency. We always know that maintenance is important, but it's always an afterthought. If this is just one more way you can get it pushed through your company, is looking at it, if your burner is not properly tuned, you are wasting gas. You're paying for that gas that you're wasting, and that gas is creating more CO2. So, there's a direct connection there. So it deserves to at least be talked about from a sustainability standpoint, which is looking, beyond just carbon footprint and looking at the whole process of environmentalism. And the amount, because we all know water's an issue. It's, if you're on the west side of the country, water's a real issue. And I don't think that's going to unfortunately go away either. So when you think about how much water you throw down the drain every year, so 1 gallon a minute going down the drain is 125,000 gallons annually. That's just a shocking statistic to me, but we don't think about it when we extrapolate these things out annually. So it is something to, worth considering when you think about your drag out and stuff. Titration. If you have to dump your chemical, you have to dump your tank because you didn't titrate it right, you got to start over. Again, the maintenance of all your processes directly relate to your costs and your footprint. And if we think about insulated walls, that's a pretty straightforward thing you can do with your washer. Our view is that the tanks is really where you get the most benefit because that's where the hot water sits. So you need to insulate there. There is some thought about insulating tunnel walls, and that does have some benefit. But the realities are your water is supposed to be ideally hitting the part, and it's going through air, so it's going to cool just by going through air. But the idea is you want to get it into your tank as quickly as possible so you can keep it heated. But those are the type of things that you can do on the washer side. But in reality, it's the ovens. That's where all the gas goes. The gas is consumed by the ovens. That's where all your vast majority of consumption is going to be. So if you're really looking at reducing, if you're a powder coater and you are looking at decreasing your carbon footprint, the place you need to look at is your ovens. So with ovens, it's real simple, just use less gas. So how do you do that? Well, one is the obvious, is use less temperature. I mean, there's a direct correlation. Less temperature means you use less gas. But that's, there's a cost to that, because the lower temp you go, typically it's more expensive powder. It's all a trade-off. Those are those costs that I was talking about earlier that you have to pay attention to. So another thing to look at is infrared. Infrared is going to be a much more efficient process from a BTU consumption standpoint, but also UV. I mean, UV uses zero heat in the actual cure process. Now it needs a thermal process to gel the powder, but using, that's typically infrared as well, but using these different kinds of technologies, they're not as easy to work with as convection is, but you can make some dramatic improvements, 50 to 100%, so dramatic. The next thing is, electrifying. You could have an electric convection oven. You're not going to love the operating costs of that, depending on how big it is, but you typically only see those in batch. But that is, without making any other fundamental changes, that is something you could do. But the easiest one you could do tomorrow is just make sure you're maintaining your burner. We can't say it enough. Whether you're lean or rich, you're looking to get to efficient use. And the other thing to pay attention to is your exhaust. I've gone on roofs before to look at how much energy is going out into the atmosphere, and we're going to talk about that in a second. But the idea of, can you recapture that heat? Can you reuse that heat? Are you even looking at that? Those are some immediate tactics. They are small in the greater scheme of things, but but they're still measurable. So I talk about this particularly because I want to talk about what is combustion. So if we're trying to get to efficiencies of a burner, you got to understand what combustion at the beginning is. And combustion, so we're taking the CH4, the natural gas, and what the chemical reaction of combustion is that it breaks apart the CH4, it with oxygen ends up making CO2 and water vapor. That is the chemical reaction of combustion. What you're always looking for is complete combustion. So that means all of the fuel, whatever hydrocarbon you're using, is being converted to CO2 and water. So incomplete combustion, typically because you're running a lean mixture, too much air and that kind of stuff, you're going to end up with CO. So it's, if you don't think about it for a second, you think, oh, well, shouldn't we just run it with more air, then we'd make less CO2 that way? Technically, yes, but you'd use more gas, so you haven't really accomplished anything. So you want the efficiencies of how the equipment is designed to be at optimal performance. So you want that complete combustion. So let's just talk real quick. If we're looking at the kinds of infrared, we've got gas catalytic, which is basically up to 1,000 degrees. That is a flameless combustion of natural gas. You've got electric infrared. It's coming off the electrical grid, but that's a very, very fast technology. They all have strengths and weaknesses. And if we look at the carbon reduction as a whole, you've got electric, obviously, is 100% scope 1. Now, obviously, there is a scope 2 implication here because electricity has its own issues. Catalytic, using natural gas, our studies show it's about 35 to 80% possible reduction. We don't say it's a direct reduction, we say it's possible. And ultraviolet, again, is 35 to 100. The 100 assumes you're using electric infrared on the front. Again, these are all scope 1s. So it's what you're doing in your plant. And this is where I was talking about the waste heat. So on the left is a convection burner exhaust stack. And you can see it's about 350 degrees at the exit. And I did not have a I always struggle with this word, oh, you know what I'm talking about, the measurement of air. I could never get the word out. I did not have one of those with me when we did that, but the volume of gas was substantive, and you could not get within 5 feet of this. You could hear it. It's a train. The next two is a thermal image of a catalytic, and then a picture of the catalytic, and it's a gentle warm breeze. So you can see someone's hand sitting on top of it. So you're not putting out as much energy, as much exhaust into the atmosphere. And that's just fundamental to how different kinds of ovens are designed. Just something to be aware of. So what I did is I took our ovens, because in our technical center here, and started running some tests. And I'm always trying, because we do both gas catalytic and electric and convection, so I'm always trying to find parts where I can do some side-by-side comparisons, so I can really see how they perform differently. And I have 2 case studies to show you real quick. This one is a light gauge formed part. I have yet to do these same parts in electric. Unfortunately, I just couldn't get to it with everything else we have going on before this speech, but that will be coming. The assumptions I basically use, so these are batch ovens. These, again, are our ovens here in our plant. And different ovens in operation are going to modulate. And there's different expectations of how catalytic, electric, or convection will modulate in use. In theory, if you had a batch convection oven and you turned it on and got to temp and you never opened the doors, it really wouldn't use that much gas. But you wouldn't be doing any work and you'd never open the doors. So, that doesn't really help you. So flow through results are very, 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 very difficult to do. And and I have a misspelling there, I apologize. The only way we can do that is we actually had side-by-side lines in the real world running the same parts. And I just don't know anywhere where that exists, where I can test. So what we did was we took a heat up temperature, because that would have no modulation. So I don't want to imply that this is practical in use. We are working on some designs and some tracking mechanisms to be able to take this to real world production use studies, but that takes time to do. So this is something we did in the lab. Again, no modulation, 100% on all ovens. So this was a catalytic oven. It took a little under 2 minutes to get to 300 degrees, that formed part. The convection oven took 4 3/4 minutes to get to 300 degrees. And this was the reduction. So this is the result. So basically, it was a 12 gauge part. This was the size of the oven. So the gas oven had 450,000 BTUs. The convection oven had 1 million, because those were the size of the ovens we were using. So this, particularly in convection, because it is driven off of load. So the amount of parts you have in there affect how fast something can heat up. Infrared doesn't care about load. So, you're not comparing apples to apples. But if we said the target temp was 300 degrees and the time to temp was 114 seconds on the catalytic and 290 on the convection, then we just calculated the BTUs used per second, and that calculation is based upon the standard that there's 117 pounds of CO2 per million BTUs, and then it's just a formula, and it came out with the CO2 generated, the pounds of CO2. So that is, the catalytic would have, in the heat up, the reduction would be 82%. So that is absolutely, I was amazed it was that high. Now, in real world application, I can't say whether or not that would hold or not, because again, there's just so many factors that are going to factor into it that cannot easily be normalized. So probably the best we're ever going to be able to do is do it based on a calculation. This is based on hard data. We would have to theorize in a real world. So this is the second test we did. This is a heavy gauge part. So here you see it before and after, and you can see where we put the oven probes, or the monitor probes on the part. And you can see it's fully cured. So it took a little under 6 minutes, 5 minutes and 50 seconds to get to 326. And you can even see on the bar here on the data pack exactly where it came out, where that 326 is. Again, that's not cure temp, that's not completed. Well, actually, I think in this part it was, but that's not how long we left it in the oven. And then it's 26 minutes to get the same part up to the same temperature. And here's the calculation on that. So this one has, this was done several years ago, and we had a smaller burner on that oven, so it was only a 400,000 BTU burner. So obviously, if you have a bigger burner, you're going to use more BTUs, but you're going to get there faster. So theoretically, the formula should come out the same. But I don't have facts to back that up. So this was a different test oven on both ovens. And again, the target was 326, and you calculate it out, and you get to a 67%. Because basically, infrared loves a flatter part. It always will. Be its most efficient on a flatter part. When you get to complex parts, you start to lose a little bit of that efficiency. Or said differently, you're raising the, electric loses it more. Catalytic still does it, but you don't have quite the efficiency you do on a flat part. So some things to consider. There's lots of conclusions that we can make through all of this. There is basically no easy or inexpensive way to reduce your CO2. All of this will require money. It will take people. It will take time. It will take resources. It will take equipment. So if you were to look at how to do it, your choices are, you're either going to have to change out your equipment, you're going to have to change out the parts, some kind of substrate change. You're going to have to change out the fuel to power your equipment. You're going to have to change your chemistries or your powders, or you're going to have to change the way you run your business. So all of these, directly relate to cost. And there's no way around that. But that's the world we're living in, and that's where our customers are taking us. I am getting more and more inquiries on the benefits of infrared from a carbon footprint standpoint than I've ever had before. Last year, for the very first time, I had somebody buy based on that. That was their primary driver. That has never happened. It had always been, oh, that's nice, but what's your price? So what's starting to change is the purchasing agents in these large companies are being tasked with reducing their carbon footprint. So much like the regulations of, a woman-owned business that obviously I would pay attention to. Big companies, if they're tasked with that, if that's how that guy is incentivized, that's what he's going to prioritize. So we are starting to see it in new equipment purchases. But if you already have your equipment, you already have how you want to run your business, the only realistic way you can make any noticeable improvement is your process. You've got to make sure you're running your process through lean, through looking at your tack times, however you run your business, you need to get your efficiencies of how to maximize your maintenance as well as your process so that you use the least amount of gas, because that's really, other than some scope 3, which would be if you were buying the powder, that would be your scope 3. Your scope 1 again is your equipment. Scope 2 again is your energy that you're purchasing. The only way you're going to make a substantive difference is to buy less gas or buy less electricity. So those are the kind of things that we tell people to think about. So as a recommendation standpoint, if you start with your scope 1, the first thing obviously you have to do is you have to know where you are. You have to know what your current state is. So somehow you have to assess, monitor, measure your current equipment, and look at your processes. You have to get a number, because if you're going to reduce your, if you're going to set a new target, you have to decide what that is compared, how will you know you've gotten there if you're not measuring? And then obviously it takes you down the road of where can you make changes, can you upgrade or change equipment? But if you do make any investment, that is something you should be promoting. You got to measure it. You might as well promote it. But if you start at the scope 1, that will more directly drive your scope 2. Scope 3 gets very messy very quickly, especially from a measurement standpoint. And I cannot realistically that they can expect any small business to reasonably be able to affect scope 2. And as an interesting factoid, 75% of manufacturers have less than 25 employees. So, when they look at the cost of this and the infrastructure it's going to take to do some of this, most small manufacturers don't have the resources to do this. So I'm not really sure what the implication of that's going to be, but that's the reality of the world we're living in. So why bother? If you're a small business, you only got 25 employees and you're being asked to do all this, you don't have anybody that says, let me take on a new project of getting our CO2 measured and monitored, and how are we going to do this? If you're buying new equipment, then maybe you can do a direct result. But the realities are the companies that are doing this are going to have a competitive advantage. They're going to have something they can promote and hold out, and there are companies that will care if you are doing this. There is a custom coder on the East Coast that uses they use infrared for all their curing, and they also do wastewater. They get it from rainwater. That's where they get their water from. They're not even pulling it off of. So they have a very unique approach to how they're managing, because this is something that's strategically important to them. But like all strategic initiatives, it's got to start from the top. Next thing is, we know regulation changes are coming, and what the impact of those are, we can only guess, but it's something that we all have to pay attention to and monitor, because that $370 billion that the government's getting ready to spend, that's going to do something to somebody. We don't know the downstream effects yet. We don't know if that's good or bad for us. It's going to make our lives probably harder, so I consider that mostly bad, but in the greater scheme of things, good. No one knows. But technology and innovation will be driven by this. And new products are going to come up, new designs are going to come up, new innovations are going to come up, new formulations are going to come up. That it incentivizes people to innovate. And if you can take advantage of it or actually be one of those innovators, you're going to benefit from this, because there's always winners and losers. But when we take it to revenue opportunities, the EV market, oh my God, it's just growing at such a rate, it's just beyond words. They just announced in Kansas City, we're going to have a $6 billion battery plant going in. It's just an unbelievable investment. But there are a lot of low temp applications on different industry, composites, wood, MDF, all those kinds of things. And those are driven by innovations, and those are the kind of things we can do. But the realities are, electrification as a whole isn't likely to happen. But don't assume that just because electrification won't happen to us, that there are not steps that we're going to be asked and maybe forced to take. So that's kind of where I end. I am open to questions.
All right, thanks, Marty. Couple questions that came up. One, in the very beginning, they did a lot of clarification when you talked about natural gas purchase would fall under scope 1, direct emissions, as use of natural gas typically results in direct combustion and emissions on site. And I think there was a question is difference between scope 1 and 2 for natural gas.
It's a little confusing. The scope 1 is if you have an oven and you look at how much CO2 am I generating by running that oven. So if you can reduce your gas purchases, you're directly reducing your scope 1. Your scope 2 is looking at the type, the amount of energy you're purchasing. So when it hits your door. So scope 2 is when it comes into your plant. Scope 1 is when it's in your plant. Maybe that's a clearer way of identifying it.
Okay. And I think you may have covered it, but the source for your claim about results with 50 to 100% CO2 emissions, that was all testing that you had did in your plant, or were there other sources that you went out to get?
No, that is all direct testing we did in our technical center based on, because my view is that education is really where the industry needs, we all need data on this. So I don't have a dog in that fight because I can look at all the different technologies. So I'm trying to be as agnostic as I can and not distort the results, because it's really easy in these kinds of tests to distort the results. So that's the reason I caution those percentages that I gave on reduction are only based on the heat uptime at 100% use. That's not a real world number. That's not an application number. That is a test number. It's a valid number, but it's based on a specific portion of the process. It's going to be we're going to have to extrapolate to get to a full application number, because unless somebody plans on building 3 side-by-side lines, one in electric, infrared, one in gas, maybe one in UV, and then one in convection, and then you ran them all together, that's the only way you get to a real world. And we know that's never going to happen. So that was how we did the scope.
Okay. Question on if you don't have gas meters fitted on individual ovens, can BTUs be calculated or estimated?
It can be estimated, but that's that's the rub, is that most people measure their gas based upon multiple pieces of equipment. So, how do you get at it for the finishing side? Those meters cost money, and most people can't cost justify. But trying to do this maybe can help it cost justify to put those meters in, so you can start to see the direct impact. But very few people have it metered by piece of equipment.
Okay. Do you see a future when on-site hydrogen generation, storage, and consumption makes financial sense?
Oh, maybe in 20, 30 years. One of the some of the things that I've seen is that I've heard people talk about is EPRI. It's called the Low Carbon Resources Initiative, and you can Google that. EPRI's part of that, who's part of IHEA, and that's the Electric Producers Resource Institute, I think. And there's one on the gas side too, whose name escapes me. And what they do is they research all these different technologies, and they have joined together to make the Low Carbon Resource Initiative. And it's electric, gas, all kinds of different energy producers, as well as large OEMs and engineering firms. And they've all grouped together to create this research to try and find out what is realistic, what can be done, what should be done. One of the assumptions they're making at this point is that our industry is not going to see a huge amount of electrification. It will affect us, but it's not going to revolutionize us. There's a lot of concerns so that's the reason they've been pushing hydrogen more. But hydrogen has some pluses and minuses that have to be dealt with. It's much more flammable. It burns at a different rate than natural gas. And statistically, so far, the amount that they can add doesn't make a big enough difference to maybe cost justify going through the work. They don't know yet. But innovation, at the speed innovation is changing, can we predict what we're going to see 5 years from now? No. But today, what they are predicting is that hydrogen, it may end up being more, like the steel industries are looking hard at it to try and figure out if that's something that could really help them, because they are really going to be hit hard if there is any regulations on this that force carbon reduction. It's the manufacturers of steel that are really going to struggle, and cement. That's another big industry.
Yeah, someone just shared that the EPRI is the Electric Power Research Institute.
Thank you.
If anyone wants to Google that to find more information, and they do have some, well, there's a lot of charts, a lot of information, a little hard to digest in some of them, but the information is out there.
Well, that's kind of why I wanted to do this, is because it seems like all the information coming out is either at a very technical level where you have to kind of be down in the weeds, or it is at a media level, which sometimes conflicts and is very summary and doesn't really help us in what we do for a living to be able to absorb it and say, okay, at least now I have a basic understanding. That's what my goal here was.
Okay. Moving forward, is there any recommendations you have for people to sort of monitor this, or is just sort of finding some of these sites and just checking back with them on occasion?
Well, what I do is I have a few, I'm always, I've signed up for a few lists. There is one, you'll always see some interesting articles coming out. When I Googled everything to find what has been published in our industry, industrial heating, process heating, powder, all that kind of stuff, there's not much. Our industry hasn't gone real far on this yet. We will. The furnace industry, because they use a lot more energy, has been a little ahead of us. So I've been getting some of this through IHEA. There are a lot of research organizations out there that are putting out a lot of data. But the energy, the EIA, all those kinds of groups are putting out a lot of data. But there's not one place you can go to get all this data. It's either you're into it and you follow it, or you just look for something else. At our powder coating PCI annual meeting, we had a speaker from EPRI, and it was amazing information, but it was a little in the weeds. And so if you're at beginner level, we all of a sudden got a lot of information that is beyond where a lot of people are in their understanding. But it was fabulous data. I've been paying attention to it. I've heard this speech now 3 times, and I get more and more out of it every time. But that's what I do for a living, is to pay attention to this.
Okay.
Google.
Right. Okay. All right, can you get us through the last couple of slides? We have some informational things just to pass on to everybody. Just remind everybody, if you are not receiving the Powder Coated Tough magazine, there are a lot of issues, and this is one area that we try and keep up on as new technology and as things are changing. It's a free subscription. You can get it either in print or digital in the US, digital anywhere outside the US. So click there, go to powdercoatedtough.com and register. Next slide. And again, we also do have a Spanish edition for anybody that prefers to read in their natural language, if Spanish happens to be it. And one more. And don't forget that in February 6th to 8th, we do have our powder coating week in Orlando. We will have a lot of technical conferences. You can watch for the postings on the different speakers and presentations that will be going on there. Just follow us again on powdercoating.org, and you can find out a lot of good information on there. So other than that, I want to thank anybody. If some questions come up later on, feel free to reach out to me. I will get them passed on to Marty, and we will try and answer as best we can. But otherwise, I'd like to thank you, Marty, and thank all for attending this webinar. Don't forget to check out the magazine online and subscribe. And watch for the link, the survey that comes up as soon as you disconnect today, and just take a few moments to give us your feedback. And I'd like to say have a great day for everybody else. Thank you.
Thank you.